Welcome to The Explainer. I'm absolutely thrilled to have you here. Today, we are diving straight into the intense, really high-stakes mechanics of landing an aircraft completely without the use of its flaps. It's a maneuver known in aviation as the flapless approach and landing, or FAL. Which really begs the question, right? What actually happens when those flaps fail, or when extreme weather suddenly forces your hand? We're so used to how heavily a steep, slow descent relies on them. So when flaps are suddenly just out of the equation, the entire physics of the landing completely changes. And it shrinks those margins for error down to almost zero. Section 1. Why land without flaps? So, a flapless approach and landing is officially defined as an engine-assisted approach to land an aircraft without the use of flaps. Now, that phrase, engine-assisted, is absolutely the big takeaway here. Because we don't have that crucial drag from the flaps, we're going to have to rely heavily on engine power just to manage our glide down to the runway. But why would you abandon a perfectly normal landing protocol in the first place? Well, it generally boils down to two main scenarios. First up is strong, gusty winds. In really turbulent air, actually keeping the flaps up prevents the aircraft from getting tossed around so much. The second scenario is just purely mechanical. The flaps just fail to come down, which forces you into an instant adaptation. Section 2. Extending the downwind leg. Okay, so jumping into the procedure, the overall circuit pattern actually remains the same, but the downwind leg has to be significantly extended. And why is that? Well, it's to cater for the extraordinarily low drag you're going to have on finals. Without flaps, you have way less aerodynamic drag, and that honestly changes the entire geometry of the approach. Simply put, you just need a lot more room. To put that into perspective, think about a normal approach. You typically begin your descending turn when the runway threshold is sitting right at your 8 o'clock position. But for a flapless approach, you have to wait. You literally extend that downwind until the runway is way back at your 9 o'clock. I know, it feels incredibly unnatural for a pilot to wait quite that long, but you absolutely must build in that extra distance. And once that runway finally hits 9 o'clock, the multitasking really kicks into overdrive. Let's look at the turning base checks. Step 1, you look around, ensure your turn path is completely clear. Step 2, you reduce throttle to exactly 1500 RPM. Step 3, you're checking that your bank is correct, the slip indicator ball is perfectly in the center, and your VSI is, in fact, showing a descent. It's this rapid-fire sequence of highly critical checks, and it requires absolute focus. Section 3, the final approach glide. 75 to 80 knots. That is the magic number. It's the critical window in this phase of flight. As soon as you roll out onto that base leg, you've got to adjust throttle and trim to maintain this exact approach speed. If you go too fast, you're going to overshoot. Too slow, and, well, things get incredibly dangerous. Proper trimming does the heavy lifting here to naturally hold that precise speed. Now, once you're trimmed, managing your energy state becomes a really delicate dance. Here's the golden rule. You control your rate of descent with power. You pull back to drop faster or add power to shallow it out. But you control your speed with attitude. Push the nose down to speed up, pull it up to bleed speed off. So power for altitude, attitude for speed. It's a foundational concept for sure, but it is highly, highly amplified when you don't have flaps. Okay, so now the runway is sitting at your 10 o'clock position. It is time to carry out that descending turn to finals. During this turn, you've got to constantly adjust your bank angle for the wind because you're aiming to roll out perfectly along that extended runway center line. And if there's a crosswind, you might actually need to keep the nose offset, basically crabbing into the wind, just to stay straight relative to the ground. Oh, and of course, definitely don't forget to obtain your landing clearance. Now, I want you to imagine looking outside the cockpit window. The sensory changes here are stark. It's arguably the most jarring part of the whole procedure. Let's look at these flapless visual realities. Compared to a normal approach, your flight path is much flatter. Your rate of descent is lower, but your approach speed is noticeably higher. And to maintain lift without those flaps, you have a much higher nose altitude. So what does all of that actually mean for you in the pilot's seat? It means poorer forward vision. The nose of the plane is literally blocking your view of the runway way more than usual. It feels incredibly alien, honestly. It's kind of like you're trying to land while looking through a tiny letterbox.
Section 4, touchdown and landing wrong.
All right, the ground is coming up fast now. The absolutely crucial point here is making exact, incredibly gentle inputs. Just before you hit the threshold, you must adjust the throttle to round off your descent. At this super low height, you're trying to gently fly completely parallel to the ground. You pull this off by reducing the throttle while simultaneously controlling your sink by changing your attitude. Keep in mind, you're managing this entire massive machine completely without the helpful drag of flaps slowing you down. And because of that total lack of drag, the flapless landing traits at touchdown are drastically different. First off, there's way less attitude change required during the roundout, and your roundoff height is much, much lower. But honestly, the wildest part? It's the prolonged float. The plane literally just wants to keep flying. And when those wheels finally do touch down, your speed is higher, which means you're going to have a significantly longer landing run before you finally come to a stop.
It really is a beautifully delicate operation. It requires just intense focus and on-the-fly adaptability, which leaves us with this final thought for today's explainer. How does changing one small variable, like the drag provided by flaps, completely rewrite the rules of physics that a pilot relies on every single day? It really goes to show you how deeply interconnected the forces of flight truly are and how human skill has to immediately step in when the machinery changes. Thank you so much for joining me to explore this today. Until next time, keep your eyes on the skies.